All right, guys, Mr. Antonucci here, and in this video, we're going to talk about how to do implicit differentiation. And at the end, I'm going to go over a couple AP style questions, so make sure you stay tuned for that. So when we talk about implicit differentiation, we want to clarify by what we mean by implicit versus explicitly defined functions. So an explicitly defined function is a function expressed in terms of x. And there are functions that you can pretty much write in the form y equals f of x. So y equals x squared, y equals sine of x cubed minus 4, so forth and so on. Equations that you're used to working with. However, implicitly defined functions are not explicitly solved for y and may not be able to be solved for y explicitly. So for example, if you have the equation of a circle, that is an implicitly defined equation. Now, you can solve this for y, and you would have to have plus or minus square root 1 minus x squared. However, you would end up with two distinct functions here, the positive root and the negative root. However, there are some equations that really can't be solved, such as, and in the case where we want to differentiate these, this is where implicit differentiation comes in. So to start this off with an example, we want to find the derivative of xy minus 4 equals 0 in two different ways. The first way we're going to do it is we're just going to solve this equation for y and then differentiate it from there. So if we solve the equation for y, you would end up with y equals 4 over x, which we could rewrite as 4x to the negative 1. And then dy dx equals negative 4x to the negative 2, so negative 4 over x squared. However, if we leave it as an implicitly defined equation, to differentiate, we assume y is a differentiable function of x and then differentiate both sides with respect to x. Basically, we're going to take the derivative with respect to x of both sides. So when we take the derivative of x times y, we would have to use the product rule. The derivative of the first, x, is 1 times y plus x times the derivative of y. We would just express that with dy dx. Then minus the derivative of 4 is 0, and that also equals 0. And then if we solve this for dy dx, we would subtract y and divide by x. So dy dx is negative y over x. Now you might think, well, those two look completely different. However, if you substitute what y is equal to, so y equals 4 over x, into this equation here, it would simplify to negative 4 over x squared. In most situations, we're not going to know the explicit form of the function like we did in that previous example, so we will have to leave the derivative expressed in terms of x and y. So this example is going to help us work through that. Now, if I take the derivative of this, I would just write d dx, put everything in parentheses. The derivative of x squared with respect to x is just 2x. Plus, now here's the thing. Y squared, you're treating y as a function. So you think of that as like f of x squared, in which case we would use the chain rule. And what I mean by that is it's a power function, so 2y technically to the first power times the derivative of the inside. Well, if we treat y as a differentiable function of x, the notation for its derivative is just dy dx. And that is going to be equal to 0 because the derivative of a constant is 0. Then we want to solve for dy dx. So you would subtract 2x, divide by 2y, cancel the 2's, and you'd have dy dx equals negative x over y. So now we have the derivative in terms of x and y. And this brings up an important situation. Whenever we have a y and we are differentiating implicitly, it's important to know what to do. So I have a couple examples here. If I want to find dy dx for these 4 different situations, if it's just y, the derivative of y is dy dx. That's just the notation. If you're taking the derivative of y squared, again, with respect to x, you do it like we just did the previous one. Differentiate with the power rule, so 2y. Then you have to treat y as a function and apply the chain rule. And the derivative of the inside, which is y, is dy dx. So then if we take the derivative of y cubed with respect to x, that would be 3y squared times dy dx. And then finally, in general, if it's y to a power and I take the derivative of it, it's going to be n times y to the n minus 1 times dy dx. So I think it's good just to practice a couple of these just so we can see how the pattern works out. Now in this case, we want to differentiate dy dx, the entire expression. So the derivative of x squared is just 2x minus xy squared. So we would take the derivative using the product rule, but since there's this subtraction here, what I like to do is put the product rule in parentheses, so I remember to subtract everything. So derivative of the first times the second plus the first times the derivative of the second. Y squared would be 2y times dy dx, and that's going to equal 4 times dy dx. Now at this step, notice a couple things. Number one, you have multiple terms with dy dx, and they're on both sides of the equation here. Problem said to find dy dx. So what we do is we collect our terms with dy dx on one side, and the terms without dy dx on the other, and then we solve for dy dx. The first thing we want to do, distribute this negative. So you have 2x minus y squared. Collect my terms with a dy dx on the left side and leave everything else on the right. So notice in the left side, we can factor out dy dx. So we will do that next. And then finally, to solve for dy dx, we divide by the quantity there. And there you go. So in summary, the steps for implicit differentiation. First, assume that y is a differentiable function of x. Differentiate both sides with respect to x. Then collect all the terms with dy dx on one side. And then solve the resulting equation for dy dx. In this situation, we want to find the equation of the line tangent to the graph of this implicitly defined function at the point 1/2 comma negative 1/4, and then we want to graph it all together. So to take the derivative of this, we differentiate both sides with respect to x, so you'd have 6x plus 8y dy dx equals 2. Solving that equation for dy dx, you would subtract the 6x and then divide by the 8y. And then all of that can be reduced by a factor of 2. If we evaluate this at 1/2 comma negative 1/4, we plug that in, we would have, and that's all going to simplify down to 1/2. So now we have our point, we have our slope, we can write the equation of a tangent line. It's going to be y equals negative 1/4 plus 1/2 times x minus 1/2. And then we'll hop over to Desmos and graph it. All right, so we have the implicitly defined equation here. Then we have the point and the equation of the tangent line, and we can see that the point is tangent to the curve there. So here we have a situation where we're going to have to use the chain rule with implicit differentiation. And remember, implicit differentiation is kind of the chain rule already. So if we look at this one, tangent squared y equals e to the x, tangent is inside the squaring function and y is inside tangent. So if you like to think of it as tangent y squared equals e to the x, that's sometimes helpful. And then we differentiate that with respect to x. So the 2 comes down, we'll use the general power rule here. Tangent y to the first times the derivative of tangent, which is secant squared y. But since y is treated as a function, we have to multiply by dy dx. And then the derivative of e to the x is itself. Then we just solve for dy dx. Here's another example, cosine of y squared equals xy. In this case, the y is being squared, not the trig function, so this would be negative sine of y squared times 2y times dy dx equals, now we have to do the product rule, derivative of the first times the second plus the first times the derivative of the second, which is dy dx. Now we're going to keep the terms with dy dx on one side and everything else on the other. And we can subtract the x dy dx. Then we factor out a dy dx, and you can also factor out a negative. Then the final step, just divide by everything to get dy dx by itself. Now I want to get into a couple AP style questions. This is from a previous free response question, and a lot of times there is a question where you have to do implicit differentiation, and one of the first steps, often they will tell you what dy dx is, but you have to show the work. So let's walk through that. Here you have a product minus another product, so we'll have to do the product rule and be careful with that subtraction. So derivative of the first times the second plus the first times the derivative of the second minus the derivative of the first, which would be 3x squared y. And I'm also going to carry the negative with it. So it would be plus the first times the derivative of the second, but I'm going to distribute the negative at the same time, equals 0. Then I'm going to collect this term and this term together and factor out the dy dx at the same time. So I'd have equals, I'm going to subtract this term and add this term to the other side through. And then finally divide by that quantity. And there we have it. So here we have the second part to this question. We want to find the x-coordinate of each point on the curve where the tangent line is vertical. So if you have a vertical tangent line, that means the equation's slope is undefined at that point. Since we have a rational type expression here, this is going to be when the denominator is equal to 0. So if I take 2xy minus x cubed and set it equal to 0, I can factor out an x and would have, this means that x would have to be equal to 0. In this one, that 2y minus x squared would have to equal 0 also. Here, this x-coordinate of 0, if you plug that back into the function up here, is not going to be a solution. So we eliminate that, because if you plug 0 in, then the equation would say that 0 equals 6, which is false. Then if we have this second equation here, what we can do with this is solve this for y, and then substitute that into the original equation where there's a y. So it would be x times y squared, so x squared over 2 squared, minus x cubed times y, which is also x squared over 2, equals 6. We simplify that. Well, that's like 1/4 minus 1/2, which is going to give us negative x to the 5th over 4 equals 6. If we solve that for x, x would equal the negative 5th root of 24. And that's it. All right, guys, hope that was helpful to you. Reach out if you have any questions. Also, make sure you subscribe and like this video and leave me a comment below and let me know if this video was helpful to you.